In this video, we're going to be looking at 3 super thick math books. I mean, look how thick these books are. Yeah, I mean, completely insane. These books will help you learn calculus. You can use these for self-study. And because these books are just so thick, you can actually do tons of problems. And you don't even need to get all 3. Even just one of these books has, I mean, I don't even know how many problems these books have, but it's completely insane. I mean, just look at that. Just incredible. Okay, let's take a closer look at these super huge books. The first book I want to show you is one that I used when I took calculus long ago. It's Calculus by James Stewart. Now, James Stewart passed away several years ago. He was a Canadian mathematician and he was a multimillionaire. In fact, he had a house designed for himself in Toronto known as the Integral House. So really, really interesting story there. So this book is awesome because it has so many topics. Now, it's not a perfect book, but it's still a pretty good book. Let's take a look at the table of contents. This is the table of contents. It starts with functions and models. Then it goes to limits and rates of change. This is typically where most calculus courses start. So if you wanted to start your course of self-study, you would start with this chapter here. Then it goes on to derivatives. Talks about all of the things that are usually taught in a basic Calculus 1 course in college. And then some applications of differentiation, stuff like finding maximums and minimums, the mean value theorem, some graphing, and some word problems. It ends with Newton's method and some basic integration techniques in the section titled Antiderivatives. Chapter 5 is on integrals. This is where he defines the definite integral. Chapter 6 is more on applications of integration. 7 is on inverse functions. So here he talks about exponential functions and logarithmic functions. And then chapter 8 is really when it gets into the integration. This is typically taught in a Calc 2 course, stuff like integration by parts, trigonometric integrals, trig substitution. That's the one that people always remember because out of all the integration techniques taught in a Calc 2 course, trig sub is the one you look back on and think, whoa, wait, those problems were super, super long. 9 has some other things on integration like arc length and area of a surface of revolution. Chapter 10 is a section that's usually skipped in most calculus classes. It's on differential equations. 11 is on parametric equations. 12 is sequences and series. This is often considered the hardest thing in a Calc 2 course. So if you're trying to learn this on your own and you're struggling, don't worry, it's totally normal. Then 13 starts Calc 3. So this is vectors and the geometry of space. 14 is on vector functions. Some of the problems here can get a little bit messy, especially when you get into some of the curvature stuff. 15 is on partial derivatives. This is actually not a very difficult section, especially the first few little sections in this chapter. They're actually pretty simple, and honestly, even with just a little bit of calculus knowledge, you could jump into this and learn a lot of this stuff. Chapter 16, it gets a little bit harder with multiple integrals. 17 is on vector calculus, and then 18 is often a section that is skipped in a normal course. It's on second order differential equations. And this isn't really hard. This is just something that you learn in like a differential equations class instead of a calculus class. So the best thing about this book is that it has so many sections and it covers so many topics and it has so many problems. There's tons of problems in this book that you can use and learn from. And not only that, this book, like many others, has solutions to most of the odd numbered problems. For example, this is 8.2. Let's go ahead and look in the back of the book. Here you see the solutions for 8.2 and you see most of the odd numbered problems have solutions. So 1, 3, 5, 7, 9, 11, etc. So it's a really nice way to learn, right? You just do some problems and then you check your answers in the back of the book. Unfortunately, you don't have answers to the even numbered problems, but this is definitely better than nothing. And you'll find that the further you go in math, the more advanced books tend to have less solutions. One of the biggest complaints that people have about this book is one of the complaints that they have about several books when it comes to math books. It's that it's not perfect and some of the explanations are actually not great. Here's an example where they explain the equation of a plane, and to me this makes sense and I think it's great, but to someone who is new to calculus, they might not feel the same way. I remember when I used this book, when I was a student, I would read certain things over and over and over, and I just wouldn't get it. So it's definitely not a perfect book, and I really don't think there is such a thing in mathematics, right? There is no perfect book. I think perhaps most people who get this book and try to read it will have the same experience I did. You'll understand some of the stuff, but you won't understand all of it. And that's okay, and that's normal. Really, the best thing about this book is you read it, it's got tons of topics, you try to learn what you can, and then you jump to the exercises and you do as many problems as you can from the exercises, and then you can check your answers in the back of the book. So that's what it's good for. It's good for doing problems and for learning math. But again, it's not a perfect book. Again, this one is called Calculus by James Stewart. There's another one called Calculus Early Transcendentals that's also equally good. The easiest way to get these is, well, one, I will leave a link in the description so you can check it out there. Or two, just go online and search for Calculus by James Stewart and just try to get any edition, right? I always think any edition is better than no edition. They're all pretty much, very, very similar. The next thick book that we're going to take a look at is Calculus by Larson, and this is actually the instructor's edition. So I have used this book to teach calculus before, and I'm really, really familiar with this book, mainly because, again, I've used it to actually teach the classes Calc 1, Calc 2, and Calc 3. So compared to the Stewart book, I think it's also very good. There are certain things that this book does better than Stewart, and there's certain things that Stewart does better. Really, they're both about the same. This book also has really, really good exercises. Here is the section on L'Hopital's rule, and you can see there are tons of examples. And just like the Stewart book, it has solutions to all of the odd-numbered problems in the back of the book. So it makes it really, really easy to use as a source of self-study. This is the table of contents, and we'll go through it fairly quickly because it's pretty much the same as the Stewart book. All of these books are very standard in their material because they're used all over the US to teach Calc 1, Calc 2, and Calc 3. Also, I think in Canada, especially considering Stewart was a Canadian mathematician. So we've got differentiation, applications of differentiation. Then we've got some basic integration here, including the definite integral, because we've got Riemann sums and stuff like that. Logarithmic and exponential, differentiation and integration, some differential equations, and again, this is a section that's often skipped. Personally, I do cover a little bit of DE when I teach Calc 1. And then some applications of integration. This is mostly taught in Calc 2. Here's the notorious disk and shell method. That's really, really hard for people. Also, fluid pressure and fluid force. That's pretty cool and very similar to the methods used in disk and shell. So once you learn how to do this, it's pretty easy to learn fluid pressure and fluid force. Then it goes on to L'Hopital's rule and improper integrals, infinite series, which is one of my favorite chapters, conics, some Calc 3, always starts with vectors in the plane, just like the Stewart book, vector-valued functions. Then you have multivariable functions, or functions of several variables. Then we go to 14, which is multiple integrals, and then 15 is vector analysis. So very, very similar to the Stewart book. This book also has some more challenging problems. For example, here it asks you to do a proof, and then here is another proof. So usually you'll get some challenging problems near the end of the sections, which is really nice. And the same is true in the Stewart book. So you get a good mix of easy, medium, hard, and then some harder problems at the end. As far as the readability of this book, I would say it's very similar to the Stewart book. There's nothing really amazing that sets them apart in my opinion. They're both pretty good, and certain sections in certain books are a little bit better and they're covered a little bit more thorough, but for the most part I would say they're pretty much equals. Here's one of the more obscure topics that's typically not covered in most calculus courses. I feel that most instructors skip this, myself being one of them. I've taught this before, but I usually don't cover it. It's on error analysis, so it's got all kinds of math that you've probably never seen. So which one should you get? Should you get the one by Larson or should you get the one by Stewart? At the end of the day, it doesn't really matter. My advice would be to get both if you can afford it. Again, this one is Calculus by Ron Larson and Bruce Edwards. Okay, let's take a look at the very last book. So this last book is currently my favorite book, that's right, and it's for a really weird reason, and I'll tell you what it is in a minute. This is Calculus Early Transcendentals, and it's by Briggs, Cochran, Gillette, and Schultz. And I'm just gonna open it up, and let's just take a brief look at the contents. And I'll just go ahead and tell you, the reason I really like this book is because I don't have as much experience with this book as I do with the other ones. I recently picked up this book. Someone actually gave it to me, a friend of mine. And so it's like, whoa, I've got a new calculus book. I've done some problems from this book and I've looked at some of the sections and I like it. It's just a little bit different. It starts with functions, then it goes to limits. So very similar to the other books. Derivatives, applications of the derivative, then integration, applications of integration. So again, very, very similar. Logarithmic, exponential, and hyperbolic functions. Here it goes into integration techniques, all the basic stuff that you would learn in a Calc 2 course. Some differential equations, sequences, and infinite series. Then power series. Then over here we have parametric and polar curves. Then here Calculus 3 starts. Again, vectors in the plane, very typical, almost identical to the other books. Vector valued functions, and then functions of several variables. There should be a couple more sections. Yep, multiple integration and vector calculus. And it finishes again with second order DEs. As before, you have solutions to all of the odd numbered questions, which makes it really, really good as a source of problems. Here's the section on integration by parts. And as you can see, there are tons of examples. And again, you have solutions in the back to the odd numbered problems. And the reason that this is currently my favorite book, again, it's because I haven't done as many of the problems from this book as I have done from Stewart and Larson. I used Stewart to take the course, so I did tons of problems from that book. And I have used Larson to teach the course, so I've done tons of problems from that book as well. But this one is one that is a little bit newer to me. And I always think it's really fun when you get a new book. Just the problems are a little bit different. You'll see problems and you'll think, oh, that's kind of cool. You know, you never know what you're going to find when you're looking at the exercises in these books. It's always like a really incredible surprise. The book has really cool pictures and it explains the concepts really well. Very similar again to the Stewart and Larson book. You might read some stuff and it might not make sense, and you'll read some of it and it will make sense. But I like it a lot and it's currently my favorite out of the three. And again, simply because it's a little bit more new to me. If you're wondering, should you get it? I say yes, especially if you can afford it. I mean, it really doesn't hurt to have tons of math books. Overall, I think all three books are pretty good. They're great for self-study because they have so many problems. If you're looking for a good calculus book where you can do practice problems from, I think any of these is an awesome choice. I hope this video has been helpful. Good luck.